All right, greetings, YouTube. Beautiful mind here. This question comes in from Applied Statistics. It's on the coefficient of variation. Hopefully, you can see this. We have this question. It comes from section 2.4, question 45. And the question states the coefficient of variation describes the standard deviation as a percent of the mean because it has no units. We can use the coefficient of variation to compare the data with different units. We're asked to find the coefficient of variation for each sample data set. What can we conclude? So what this is just another way of kind of describing how spread out the data is. Keep in mind that in our discussion, the variation of the data set tells us how spread out the data is, and the standard deviation tells us how far away the data is from the average or from the center. So this is all central tendency discussion. So let's pull up a copy of the data set. I meant to do this beforehand, but that's kind of how these things go. So basically, we're going to be finding the coefficient of variation for these two different sets. Oh, come on. Okay, we'll just go with that. So yeah, I didn't mean to do that beforehand. And I'm actually going to attempt to do this by hand, but keep in mind that this, what you're about to see, you can do it in a Texas Instrument graphing calculator. You can also use Excel to crunch a lot of these numbers. I'm going to do as much of it by hand as I can, as soon as I can get this behave properly. Okay, so let's give this a go. So let's see. Describes the standard deviation as the percent of the mean because it has no units. We can use the coefficient of variation to compare data with different units. Find the coefficient of variation for each. This, again, right there it says each sample data set. So because it's a sample data set, we have to use this specific formula that we have to use for the standard deviation. So with a lot of these, the main thing is really just knowing what's the proper formula to use. So let me see if I can do it from memory. So the variance, this sample variance should be, let me see. So we're going to have x minus x bar. Let me see. We're going to do the sum of these. And since it's sample, we're going to do divided by n minus 1. And then the sample standard deviation is going to be the square root of the sample variance. And so then it's going to be the square root of this guy here. I think this is right. I'm just going to look. I'm going to glance at the formula just to make sure I have it right so that we don't waste a lot of time. So I actually have it, squared, right? Yeah, x minus x bar squared. Yeah, that's fine. Okay. So right here, we got to square each of these entries. Okay. I felt better about this. Okay. So if you wanted to do this by hand, now keep in mind we could find the variance and the sample variance and the sample standard deviation. We can use I think I could do it on my TI-84 Plus. You could also use Excel or numbers if you're on a Mac, or Excel also if you're on a Mac as well. I'm just going to attempt to do it by hand. So let me start off. Let me do the heights first. The heights. All right. So then we take each x. So then we have what? And let me introduce. Let me do some graph paper. Okay. So we'll put you here. So then we have what? 82, 74, 68, 69, 66, 79, 66, 79, 65, 79, 65, 68, 79, 68, 79, and 72. Let me see, 1, 2, 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 8, 10, 12. Okay. So So we found each x. Now let's say each x minus the average. So we need to find the average. So our x bar, we will add all these up and divide by 12. I will use my calculator. Okay. I think for the sake of time, I'm not gonna crunch all this out. I'm gonna go ahead and type this in the stat. So if I go over here to stat, I'm gonna go to edit, and I'm just gonna type in this data. I'm gonna type 82, 74, 68, 69, 66. Nope, that's not 66. 79, 65, 79, 65, 79, 65, 68, 65, 68, 79, and 72. 79 and 72. Okay, looks good. I'm going to go ahead and type in this other one as well. 226. Oh, that's not a 6. 226. 235. 204. 229. That's not a 9. 168. 188. 195. 166, and then 200. 173. 220. 193. Okay. So let's see. If we go, I'm going to quit this. If I go back to stat and I go to calculate, honestly, we can do one variable stats. So the sum of the x's, okay, x bar, right? The average. So this says that x bar, our average is, I'm going to round it 72.17. 72, I was going to say approximately. Or actually, I can do 1/6 bar, right? Okay. So again, x bar. Okay. So then if we were doing this by hand, we would say x minus x bar. So we would say each of these minus that average. Okay. You would get an answer, and then we would take those answers. So that would be the next part. I'm going to skip that. Then we would take each of those and we would say x minus x bar squared. We would get another set of answers. And then at the end of that list, we would add all those up. So if we say the sum of the squares, let me see. I don't think I'm reading this right. Okay, let me think about it. Well, I don't know that I'm seeing what I'm looking for there, so I'm not going to transfer the number. But the idea is there, right? So we have our average. We would say this minus 72.16, we get an answer. Minus 72.16, we get all those answers. And then we take those answers and we square them, and we get those answers. Then we add all those up, and we get something here. So I'm not going to write all that out for the sake of time. But then the variance, let me think about it. If that's the standard deviation, which one is the right one? Standard deviation. So one of these is the, I'm trying to think. I'm just not reading it properly. It's 12, the min, the max, Q1. They give us the, okay. Sum of x squares. I don't think it's that one. I think I'm gonna just go ahead and do it because I'm not. Let me see. It's either the sample variance or the, let me see, standard deviation or the sample standard deviation. I think we need to take that first number, but I'm going to just go ahead and do it since we have everything here, right? We could do matrix calculations. I think I can get it in one swoop. So let me see. Yeah, I'm trying to do stuff on the fly. Okay, let's just go ahead and do it. Let's do 16 bar. I want to get that fraction. Try not to waste a lot of time trying to be quick. Okay, let me do this really quickly. So say I just want to find this fraction, 16 bar, right? I want to find out what fraction it is. So say x were this. So then let's multiply this by 100. So if we said 100 times x, if we move the decimal to the right by 2, we're going to get 16.6 bar. And then say we said x times 1,000. I just want that fraction. So if we move to the right by 3, we get 166.6 bar, right? So if we said 1,000 minus 100, 1,000x minus 100x, we're going to get what? 900x. And then if we say the 166 minus the 16, these are gone. Let me see, 6 minus 6 is 0. 6 minus 1 is 5. And then 1 minus 0 is 150. I think that's okay. Equals this guy. All right. I'm just finding a fraction. I'm doing a little bit extra. So then ultimately x is going to be 15 over 90, 3 over 18, which is 1 by 6. That makes sense, right? So now, what I was doing there was just converting the 0.16 bar to a fraction because I just wanted to use that fraction. All right, so there it is there. So now we have our average. So I'm just going to go ahead and crunch all those numbers. I'm just going to move this off to the side for your viewing pleasure. If you want to use it later, you can. I'm gonna just move it over out of the way. Okay. So let's say 82 minus, let me see, 72 plus 1 over 6. Okay. 9.83 bar. 9.83 bar. If we square that answer, let me just kind of 82. The next one is 74. Right here, let's not do that. Let's just go ahead and square that answer. 96, we'll say 96.69. 96.69, right? Now, I know we're doing this step by step, but if we use Excel or numbers, we can honestly type it in and all of this we can do this actually very quickly. Let's say 74 minus 72 plus a 6. Okay. 1.83 bar. X minus that. Okay, what I'm going to do, I'm going to go here. I'm going to say X minus 72 plus 1 over 6. We get an answer. Then I want this one to be X minus 72 plus 1 over 6. Whatever answer we get, I want to square it. So I'm going to just do this a little bit faster. Okay. So let me do the y1 first. I'll just go ahead and do, so now when y1 is, actually we could just look at the table, right? There it is right there. No. stat, stat plot. We're going to turn this on. Can we change that to this? No. There is a way. I keep trying to do everything on the fly. Because I don't think this is going to work. We need to go to like 68. Can we just type that in? No. Okay, that's okay. I know we could do it in the table, but I was just trying to do it quick. Okay, let's type in our 82 and we get the 9.83 bar. We got it there. I'm gonna just go ahead and do this for all of them. 74, 1.83 bar, 68, negative 4.16 bar, 69, 3.16 bar, 66, 6.16 bar, 79. Did we do 79 already? No. 79, 6.83 bar, 6.83 bar, 65, negative 7.16 bar, negative 7.16 bar, 68, we did that one, 4.16 bar, 79, 6.83 bar, 72, I don't see that one. .16 bar. Negative. Okay. So then we want to take all those results and square those answers. So let's test the first one. If we go to variables, and I think we type that into y2. So if we type in 82, it should be 96.69. Okay. 82, and then 74. 3.361 bar. Okay. 68. 17.361. Okay. 69. 10.027 bar. 68. Let's just copy. 68 is there. 66. 027 bar. 38. 027 bar. 79. Did we do that one already? No. Mm, 694. 46. Okay. 65. 361 bar. So that one occurs a couple of times. Let's just go ahead and copy both of these. So the 51 goes with the 65 right here. 79 goes here. That's another 79. 72. Did we do that one? And then let's go ahead and do 72,027. Okay. So what we did, we're making the table. We're doing it just for the heights. Maybe I'll do this one like this, and then I'll do the next one in like numbers. So we have our data. We found the average. We said each x minus the average. Then we got those answers. We squared those answers. Then we want to add all those up. The sum of the squares. It should be somewhere in that original list that we have. I wasn't sure which one was the correct one, so I decided to just do it by hand, and then we can go back to what we generated before. Okay. Let's see. So we want to add all those up. 96.69 plus 3.361. I'm gonna just go like this to try to help it out a little bit. 17.361, 17.361, 10.027, 10.027. So this is going to be a little skewed because these are approximations. 38.027, 38.027. 46.694, 46.694. 51.361, 51.361. 46.694, 46.694. 51.361, 51.361. 17.361, 17.361. 46.694, 694. 0.027. Okay. So that'll be the sum of the squares. 425 points. Let me see. So then this one ends up being 425 point. Let's see. Let's just go 66. All right. So we add all those up, we get this. Then for the variance, we want to say that divided by n minus 1. So we're going to say, so again, for the sample variance, we're going to say that 425.66 divided by 12 minus 1. And so we're going to say that divided by 11. Did I do that right? No. That's square root. Yeah, I did the sum of the squares, n minus 1. Yeah, we're okay. So divided by 11 was that 38 point, I'm going to say approximately 38.7. And then, so for the sample standard deviation for the heights, we take the square root of that answer, square root of that answer, 6.22. Let's see, how do we do? 6.22. Okay, was the standard deviation. Sample standard deviation, that's what we got. So then for the coefficient of variation for the heights, so the coefficient of variation for the heights, it should be that 6.22 divided by the 72.16 bar times 100%. So we're going to say that divided by 72 point, or let's do it like this. The 72 plus the 1/6. And then we're going to say that times 100. Approximately 8.62. Approximately 8.62%. I think this is correct for that one. I'm just going to glance at the answer to make sure we did that properly. 8.62%, 8.6%. Yeah, that's exactly what they got. Okay. So then let's do this. Let's do something similar. So that was just for the heights. We'd have to go back and do it for the weights. I'm going to attempt to do it on the fly using numbers. Let me see. I want to look at one other thing. So if I go back to stat, I go to calculate, and if I do variable 1 stats, let's see, 6.22 6.22. So you see the 6.22 was the sample standard deviation. You see it there, the S, right? So the sample standard deviation versus the population standard deviation. The population standard deviation would have been 5.95, but the sample standard deviation, since we're doing a sample, was a 6.22. So that's the thing I wasn't sure. I didn't want to improperly read. Okay, and then let's just do something real quick. Let's go to stat. Let's go to calculate, and let's just do two variable stat. Oh, is that for the second? I think that's just for the second set of information. Okay, maybe we can use that. Okay, so since we had already typed in the second set of information, okay, let's do the coefficient of variation. So that means off the rip, we have the sample standard deviation for our weights, right? So the variable 2 tells us for the second variable we wanted the stats there. So we know the sample standard deviation is the S, the 6.22. Let me see. 7. Am I looking at the right thing? Maybe not. Let me see what's the average. Well, those are the same. So maybe I'm not reading this proper. I think. Okay. Okay, maybe this one is 23.9. Okay, let's go with 23.9. Okay. I think this, hopefully I'm reading this right. We're going to see in a moment. So then once we have that, and we have that the average is 199.75. 199.75. So then the coefficient of variation for the weights should be the 23.9 divided by the 199.75 times 100. Let's see if this works. So we're going to say this is approximately. So if we say the 23.9 divided by the 199.75, we're going to say times 100. 11.96. So we're going to say approximately 11.96%. Okay. So we got this for the coefficient of variation of the weights. We got this. Nope, not that one. 8.62%. And I think these are correct. Yeah, approximately 12. Right? So we see the solution here. So the coefficient of variation for the heights is 8.6%, and the coefficient of variation for the weights is 12%. Therefore, the weight is more variable than the height. So the weight is more spread out, right? So we're doing this. So, but you saw how we did it by hand for the most part, right? We did, so as a quick recap, I know that took a little while to kind of get it going, but now by hand, the coefficient of variation is the standard deviation divided by the average times 100. So we essentially have to find the standard deviation. So in this context, this is similar to standard deviation. So the higher the coefficient of variation, the more spread out the data is. So if we're going to find the standard deviation, again, it says a sample data set. So that means we have to use this formula for sample standard deviation, right? This whole n-1 jazz. So when we did it by hand, we were making a table. We took our data entries. We said each x minus the average. We squared those results and then added them up, and we got this. So then we use that to find the sample variance. We're going to say this divided by n-1. We get this. And then for the sample standard deviation, we take the square root of that, and we get this, right? So if that's the sample standard deviation divided by the average times 100 for the heights, we got this. And then we realized through process that what this output was telling us in our calculator. And so we realized that the S was the sample variance. Let me see, that was the sample standard deviation, right? As opposed to the sigma, which is just below it, which is the population standard deviation. But we wanted the sample standard deviation. It's very nuanced. So that's why you kind of have to like pause a little bit. So then we just used the calculator. We had already typed in the data for the weights. So then we see over to the right the 23.9 for the sample standard deviation. We also have our average, our sample average, which was the 199. I think if we go up a little bit, can Can we recall it? So there's the first one, the 199.75. That was for our second set of data. That was the average for our second set, so we took that. Coefficient of variation was basically the sample standard deviation divided by the average times 100, and we compared those two results, okay? Hopefully that wasn't too all over the place, and hopefully you can like make use of that. The first one we did essentially by hand. That was all of that stuff, right? So all of this was us doing it by hand, and then the second one, when just using the calculator and knowing what numbers we were looking for, we were able to do it in this many steps. Okay. So on that note, we're actually going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.